Good morning. Welcome to the next session of Vidnyan Samvad. Pune is known as Oxford of the East. We have large number of research institutes in Pune. These institutes create scientific culture and also contribute in nation building. Vidnyan Bharati, along with SP College Pune, are jointly organizing a series of Vidnyan Samvad, which is scheduled on every Sunday on every month. This series will focus on research activities, public outreach activities, achievements of the institute, and various career opportunities in the field. This is going to be a nice platform for all age groups. So mark your calendar for every second Sunday of every month. Now I request Dr. Vinayak Solapurkar, sir, Principal of SP College, to address the gathering. Sir is PhD in mathematics. He is a well-known national speaker. He was one of the referee for National Olympiad Committee. Sir is chief coordinator for Madhava competition, which is held across 23 centers in India. Sir is associated with Bhaskaracharya Pratishthan, and sir is also associated with Vidnyan Bharati for several activities for various years. Over to you, sir.
Thank you, Mukul. Good morning, everyone. Let me first thank all the organizers for inviting me here today and providing an opportunity to participate in this very innovative program. Good morning, Professor Raychaudhury. On behalf of SP College, I thank you for sharing your valuable time for everyone around here. Thank you very much, sir. Your inputs are going to be most valuable for student community, schools as well as colleges in Pune, and for all those who are watching this program. Let me just talk for 2 minutes about SP College. SP College is a very well-known, renowned educational institute in Pune, founded in 1916, so more than 100 years ago, in a nationalist movement. And then there are many achievements, of course, in last 100 years in the field of culture, education, sports, and especially very last 50, 60 years. Originally, it was more known for arts college, but of late in last 70 years, it has made its marks on the scientific community of Pune as well as state and national level also. Many of our renowned students have been working in several areas, including pure sciences like physics, chemistry, biology. There are many who are working in the institutes like IUCAA, ISER, and so on. So needless to mention that college has contributed immensely in the field of education for many years and has got association with many institutes in and around Pune. I was also associated with ISER, IUCAA. Professor Dadich was my teacher in the Department of Mathematics when I was taking education. So Pune is a cultural and scientific hub. And recently there was an article where many scientists featured in the great achievements in the field of research, and they come from Pune. So this scientific temper, I'm sure this series will cultivate, and these speakers like Professor Raychaudhury are extremely renowned scientists in their areas, own areas, and their inputs will imbibe a spirit of scientific culture in the minds of students. See, there are many things that I can talk today, but there is no time. But looking at getting your career into pure sciences, there are lots of hurdle, and there is fear as well as public pressure against professional courses and things like that. But doing science is very exciting, as Professor Raychaudhury will share more with you. So it's a great series. It's a great innovation. I congratulate Vidnyan Bharati and my colleague Sandeep Kakade, who took initiative on behalf of Science Association platform of SP College to take part, to be a partner in this program. So I am very proud to be a partner in this series of lectures that will be arranged in this particular series of great scientists like Professor Raychaudhury. I thank you, all of you, for inviting me, and I am proud to share this platform with Vidnyan Bharati and other scientists here. Thank you very much, and all the best.
Thank you, Solapurkar sir. Thanks for your encouraging words. I'm sure this series is going to be a great success. Now I request Dr. Sandeep Kakade, Secretary of IIPT Pune and also in charge of Science Association in SP College, to give a brief about the activities that are conducted by Science Association, introduce our chief guest, and take the program ahead. Over to you, sir.
Thank you, Mukul sir. Thanks a lot. First of all, I will take this opportunity to introduce Science Association in brief. A Science Association is established in the year of 1966 at Sir Pershanambhava College, Pune, and the basic objectives of the Science Association is to ignite the minds of students through scientific thought and logical thinking with the help of different scientific activities, and to in community we have to encourage this science culture. So on the same line, we have proposed and organized this Vidnyan Samvad with the collaboration of Science Vidnyan Bharati. So first of all, I welcome you, respected Professor Somak Raychaudhury, and all the audience on behalf of Science Association and Vidnyan Bharati for this series that called as Vidnyan Samvad. And now I am happy to introduce Professor Somak Raychaudhury. So today's chief guest is a director of IUCAA, that is Inter-University Center for Astronomy and Astrophysics, Pune. About his education, he has completed his graduation from the Presidency College, Kolkata, and his future study he has completed from the University of Oxford and Cambridge, UK. He has been he has worked as a professor in University of Birmingham, UK, and also held the positions like head of Department of Physics and Dean of Science Faculty at Presidency College, Kolkata. He has received many scholarships and fellowships from national and international levels. He has published many research papers in reputed international journals like Nature, Science, PRL, and more the astronomical one. His research field is in the subject like cosmology and astronomy, and the area of interest is in black holes, galaxies, then superclusters of galaxies. He is the discoverer of the galaxy we call as Saraswati, and to his reputed research work, actually, he became a fellow of National Academy of Sciences, then Royal Astronomical Society, and Astronomical Society of India. So, with his few words, I welcome him on behalf of Science Association and Vidnyan Bharati, and I would like to request him to enlighten us with his presentation entitled Learning Astronomy in School and Colleges, the Story of IUCAA. Thank you, sir. Please unmute, sir, yourself.
Yeah.
Namaskar.
Yes,
Thank you very much, Dr. Solapurkar, Dr. Kakade, for this very kind introduction. So this is a series which is very promising because, as was mentioned at the beginning, Pune is lined with some of the leading institutions in the world, academic and research institutions. In fact, that has led us recently to form what is known as the Pune Knowledge Cluster, supported by the central government. We are the first city to have a knowledge cluster which brings together colleges, universities, and industry together to share knowledge. And this was prompted, of course, by the fact that we have so much going on. Also, I'm very happy to share this platform with SP College because SP College has been a part of IUCAA's activities for a long, long time from the very beginning, as you said. So I've myself interacted with quite a lot of your students, both when I worked at IUCAA in the 1990s, in the early days of IUCAA, and after I've come back as director in the last 5 years. So I'm going to share my screen to show a presentation, and then of course we'll have a discussion afterwards. So let me just share my screen. Okay. I hope my screen can be seen now.
Yes, sir.
Can it be seen? Okay. So I just wanted to tell you a little bit about what we do here in IUCAA and how and why we do astronomy. Is my slide changing? Can you see the next slide?
Yes,
Please
no
confirm.
problem.
Thank you. So IUCAA was set up 32 years ago by Professor Jayant Narlikar, as you know, who is still with us and attends IUCAA every day normally. Of course, during the pandemic period, we've had a hard time keeping him away from here because the campus has been closed. But he inspired us to start this amazing exercise that we do in IUCAA. IUCAA is a very unique institution. You can't find anything like this anywhere in the world because it was set up by the central government in the 1980s when it was thought that astronomy is such an important subject. It was taught in Nalanda and Takshashila, but it's not taught in Indian universities now. And so how to get the subject on the curriculum in Indian universities and also in schools as an extension. And so it was set up here, and our job is to primarily to interact with universities and colleges and also give the university and college teachers an opportunity not just to teach astronomy but also do research. The idea is that we are then set up, and now within these 30 years, I'm very proud to say that IUCAA has grown to be one of the premier research institutions in India for the subject and related subjects in physics and mathematics and parts of chemistry as well. And we have created a research environment for associates who belong to universities and colleges all over India. And we then have also done the reverse. We have gone and set up astronomy teaching activities in universities, and this is rapidly growing in the last few years because we now have the Pandit Madan Mohan Malavya Teaching Learning Center here in IUCAA, funded by the Ministry of Education. And what we do is we prepare model syllabuses, study material, laboratory experiments, student projects, etc., and help teachers teach these things in their own universities. So slowly we are getting astronomy on the curriculum, and of course with the national education policy now, this becomes very easy because it opens up the education system for introduction to new subjects. We are also now the National Resource Center for Astronomy and Astrophysics. So on government's Swayam platform of massive online courses, we now have online courses that are given to the entire country, and these are often taken for credit for universities. So if you're at a university where astronomy is not taught, you can actually officially take the Swayam course that we give and that will count as a course in your university. Our campus is beautiful. It was designed by Charles Correa in the 80s, of course, and has been embellished. You can see that in the central courtyard, we have Aryabhatta talking to Galileo and Einstein. And here, just off the picture, is also Isaac Newton sitting under a banyan tree. So the four of them tell us, represent the intellectual peaks of our subject, of mathematics, of physics, and of tradition, and of the subject itself. And the entire camp, the beautifulness of the campus also adds to the activity in there. People come from all over the country here to find peace and talk to each other so that they can do their work. And one of the great aspects of this architecture of Charles Correa was that the whole campus should be open. We should be able to see the sky from anywhere in the building. So we have all these very nice sight lines out into the out of the building. It's not an enclosed campus with lots of people guarding people. And the two plaques at the two entrances of IUCAA kind of underline the philosophy of IUCAA. And it's put down in Sanskrit, in Hindi and in English. And one of the, as you come into IUCAA, you see this shloka from the Ishopanishad, which essentially says, Hiranmayena Patrena, the face of the sun is covered with a golden disc, and O sun, please unveil it and show us your true form. That's the idea. So the idea is that we look up at the sky and we see an apparition, we see some sights the sky gives us, the sun gives us, but beyond that are the mysteries of the universe, and we have to learn it. And this is our motto. This is right at the beginning, at the gate of IUCAA. And the other one is a very nice quote from Bharati's one of his long poems, and it talks about the philosophy of IUCAA, which is essentially it says, what is the use of the mountain and the golden mountain, silver mountain, when trees just remain trees? We have to create the Malay Parvat, where things can come together, and everything large and small, and they can smell the fragrance of chandan from the mountain. The idea is that we have to go beyond the mundane and look at the esoteric, and look at what the universe is telling us. This is the main philosophy of IUCAA. So, and that is because astronomy is a subject which is fun, and it also has been a tradition in astronomy. The fun is from the research point of view. From our point of view, we do research. It's a very challenging subject because we can't go and touch and feel our subjects, right? If you are in a lab in biology and chemistry, you can actually change your experiment. You do the experiment many times. You can actually see what those things are. Our subjects are so far away that we can't go there. And also they are giving us information through many forms of light, and we get partial information, and it's like a puzzle. It's like a murder mystery, or it's like a detective mystery. You have to sort out a very big puzzle through the clues that you get from the universe, and you try to understand the universe. And people have been doing this for a long time, trying to understand the universe in their own ways, and now we have some tools to do that with, and those tools are physics, chemistry, mathematics, engineering, biology, and the kinds of things that we learn in college. And so astronomy is one of the toughest subjects. If you look at the curriculum of Nalanda and Takshashila, you would see the first subject that's taught is essentially mathematics and astronomy, and then you have, of course, the religious texts and philosophy and ethics and all kinds of things. If you look in Oxford and Cambridge and Heidelberg and all the big European universities in the 15th century, 16th and 17th century, you will see just these subjects being taught. What did Newton learn in his college? He learned mathematics and astronomy and ethics and theology and philosophy. These are the things he learned. And so these are the basic subjects, and astronomy is one of the most challenging things. And India in general, Bharat has been a leader in mathematics and astronomy, as you know, from the early days. I mean, that is why we have Aryabhatta in the center of our courtyard here, because he knew all about the basic ideas of the sun, of the fact that eclipses are caused by shadows, and he worked out basic mathematics to predict where the sun and the moon will be and things like that. And later on, Bhaskara first and Bhaskara second, and of course with Madhava. As you heard the name of Madhava earlier, in Madhava is somebody we celebrate because he gave us an early form of calculus. These are all motivated because these are motivated to learn astronomy. And that's why astronomy is important, because astronomy has traditionally been important because it helps us in navigation. If you want to go from one place to another, before the days of GPS, you looked up even a few decades ago, ships would use essentially the stars. And so in tradition, you want to go to the next village, you looked at the stars and you figured out where you're going, north, south, east, west, etc. You wanted to know the time for when to put your crops into the field and when to reap them. All our festivals are connected with astronomy. We know that Diwali, which is coming, is the first Amavasya after the first Purnima, after the autumn equinox. So if you don't know the equinox, you don't know all these things, and things like that. And then a lot of the celestial phenomena are important in our lives. But what has happened is that these things have motivated modern science as well. I mean, modern physics comes out of Newton being asked the question by Halley, why does this comet come back every 75 years? And Newton sat down to think about it and then developed what we call physics now. Really, I mean, all the laws of Newton, the laws of gravitation and things like that. Similarly, in our belief in astrology has, whether you believe it or not, has given us the basic tools of mathematics that are used to predict where the objects in the sky will be and when eclipses will happen and things like that. And that has led to the development of a lot of the mathematical tools that we use now. And astronomy in everyday life, if somebody comes and tells you that astronomy is useless, you can just point to the phone that is in everybody's pocket, and you can see every useful thing in it has come from astronomy. I mean, the communication, the basic phone communication is developed. A lot of it is being developed for radio astronomy, radar technology to radio astronomy. The digital camera in your phone that everybody uses was developed for the Hubble Space Telescope, really, because we knew that if we send out a camera into space, we could not develop the photographs, and the digital cameras were developed and things like that. Even the CT scan that is done in the hospitals was developed by an astronomer initially for astronomical purposes. So all these things come from the study of astronomy, even though it is not completely apparent for this. Now, at the inter-university centers, there are 3 inter-university centers currently in physics. There are many others in other subjects under the UGC. What we do is we have research and development going on here, and then we have the university programs of teaching and research, as I said, but then they all connect to the very large international programs we have, so that through us, the university teachers anywhere in the country can plug into large international activities through us. They come here, they meet our international collaborators. We are a hub, and always passing through IUCAA, you find people from all over the country and all over the world. And then on the fringes of that, we have our public outreach that includes school students and school teachers, as well as now we've only recently been nominated. I haven't signed the MOU yet, so I haven't gone to the papers to announce it, but you are one of the first people to know that we are now being given by the International Astronomical Union, IAU, as their Office of Education, one of the main offices in the whole world. There will be 3 or 4 of them, and India has been given one, and it will be situated in IUCAA. And this will look at how astronomy is taught in schools all over the world, not only in India. So the office of the IAU will decide what kind of astronomy should be taught in schools all across the world. Here is you can see all over the country, we have about 165 associates who come from all over the country. And they go back to their universities, and then they work with the schools as well as the students there as well. So we have a huge program spread all over the country. So right now in IUCAA, we have only 21 faculties. We're a small place, and 5 emeritus professors, but we have only PhD students, 62 of them, and we take about 10 to 15 students every year. Very soon, we will start a master's program with Pune University. It was supposed to start this year, but the pandemic kind of postponed it. But currently, we have a very small number of students and postdoctoral fellows, and so it's a small place. But at any given time, this place is full because we have people visiting from all over India. Now, we help the country's large projects also to connect to universities. So, for example, here's an example of ISRO's first astronomical satellite, which has been an amazing success. You hear stories coming from AstroSat. It has it was only launched 5 years ago. I was there. It was launched at the end of September 2015, and it's got 5 different telescopes, all looking at the same object, observing in X-rays, UV, and ultraviolet, and normal light. And it's one of the top telescopes in the world, but it's in space. And the science center of AstroSat is in IUCAA. And so what we do is we help university and college teachers and students to use AstroSat and write papers and do research. And so almost half of the output of AstroSat, which has been amazing over the last 5 years, has come from the universities, where people who are in teaching in colleges, they're also using this facility in space. And right now we have about 1,000 people using it all over India, and about another 500 people outside India who are also using AstroSat. IUCAA has its own telescope, which is currently out of operation, but will come back into operation soon. It's called IGO, IUCAA Giravali Observatory, which is about 100 kilometers north of here, about 90 kilometers north of here in Pune. And it's very near the GMRT. It's on the Pune-Nashik highway, but you go up a mountain, Giravali, and it is on top of a mountain, and it's a 2-meter telescope, and it's open to anybody who is part of a college university in India. And it also has been a very successful telescope. And of course, this is not IUCAA's facility, but it is the largest radio array in the world. Soon to be, of course, superseded by the square kilometer array in the southern hemisphere, but this will remain unique. It was built by the recently deceased Professor Govind Swarup, who was our great inspiration, who built the institute just opposite us called NCRA, which is part of the Tata Institute, National Center for Radio Astrophysics. And the GMRT has 30 such dishes looking at the sky at the same time, spread over about 30 kilometers right on the Pune-Nashik highway. And if you go towards Nashik from Pune, you see them on the right. And as I said, these are 45-meter dishes. And this array has been, for about the last 20 years, the largest radio array in the world. And people come from all over the world to use it. When I was in England as a faculty, I used to come 4 times a year to use it, along with my students. So, and then we in India, we have these very big science projects now in physics and astrophysics, which are taking part in big science all over the world. And this is new in India, because in our country, science has been institute-based in labs, in small institutions, and we have rarely been part of the big picture globally, and let alone lead it in big experimental projects. That we have always produced great mathematical minds, great theoretical minds, because there you don't need much resources. You can sit in your office, your room, and then do amazing theoretical work, amazing mathematical work. But to do experimental work, you need resources. Now our country has the resources, and it is sought after by everybody. So we are part of all these big projects in physics all over the world. And the first two, I'm proud to say that IUCAA plays a very, very important role. And of course, the third one, the Square Kilometer Array, which will be all over Australia and Africa, built the big radio telescope, is being led by our neighbors, the National Center for Radio Astrophysics. The 30-meter telescope that we are about to build is going to be situated in Hawaii, but India is 10% partner of it, and it is built together with Canada, USA, Japan, and China. And the interesting thing is, we are not giving the money for the telescope; we are building it here, right? So most of the money that is spent is actually spent with Indian industry. This, if you look at this telescope, it has 492 mirrors, and the whole thing is 30 meters across. If you think of 30 meters, it is the size of a house. And those 492 mirrors, 100 of them will be polished and made in India, and all 492 mirrors can be independently moved. And the moving mechanism is being made by Indian companies in India. And there are companies in Pondicherry, in Bangalore, in Pune, they're making parts of it. And the entire software for the whole observatory is being written in Pune right now. And so this will, it will take about 8 to 10 years to build it. And it's going to be the largest telescope in the world. Similarly, you probably know that the third LIGO, which is the Gravitational Wave Observatory, it will be built in India, in Maharashtra, in the Hingoli district. And these are the 4 institutions in charge of it. The 4 institutions are in Gandhinagar, in Indore, and us are the science institutions, and the civil work, the building of IUCAA, this LIGO India, which will be here, is going to be built by DCSEM, which is based in Mumbai. And this is being done in collaboration with the LIGO observatories in the US. And these are the gravitational wave detectors, which got the Nobel Prize 3 years ago for the first detection of gravitational waves. And now, with building this laboratory in India, we are going to join this whole effort by about 2026-27. So the students who are in college now or in high school will be the youngest people who will be able to use it. This is so different from when I was in school or college. I never thought that if I wanted to do experimental sciences, the top institutions are here in our country. Now, I'm very proud to say that within a few years, one will, the people who want to do world-class experimental research in physics and subjects like that in engineering will not have to go to any other country. They can do everything here. And that is an amazing concept. And these observatories might be like this in India itself, in Maharashtra, or places like Africa or Hawaii, where we are building them. And so that essentially that will be Indian facilities. We also do quite a lot of outreach, apart from the research that is done in IUCAA, and this is done with students, school and teachers. This is our Muktan Vidnyan Shodhika, which is just opposite the MVS, which comes from our association with Pula Deshpande. As you know, yesterday, actually today is his birthday, and Pula Deshpande was so impressed with IUCAA's activities that he left us a little legacy from which this building was built, and we celebrate his birthday every year with the Pulasthiya Science Festival, which is going on now, today and yesterday and today. But in here, we do all these activities for school students to come and work, and also for teachers to come and look at how science is done. And all of this goes on all through the year. And in summer, we have more activities. Around Science Day, we have more activities. If you look at our science outreach, we cater to groups of visiting school students from all over the state and sometimes from outside state, other parts of the country. But you can see, groups from Nashik, from Palwani, from Aurangabad, everywhere coming and working with us. And on Science Day, we have the last Science Day, which is at the end of February. We had 15,000 people visit us in the same day. So this is amazing the way our activities go. And of course, now we do similar activities near the LIGO site in Hingoli and in Latur district, as well as near where our telescope is in Pune district, but near Girabali. And just in the last year, if you look at the statistics, we reached tens of thousands of people in person. And what happened was during the lockdown period, in the pandemic period, that all gave us a different platform, so that we could actually interact with the whole country and the whole world and do our kind of outreach, but sitting here, not having people come here. So we grabbed that opportunity right from the beginning during the pandemic period. So as you can see, this is an example. During the annular solar eclipse that happened in June 2020, we had a program that lasted from the morning, all morning and afternoon. And you can see Professor Narlikar himself sitting in his office. I am there, and people from all over, experts talking about the eclipse. And this eclipse event was attended by 1.25 lakh people. This is nowhere we can fill our auditorium here with so many people, essentially, in any event. But this gives us, the digital platform gives us an amazing way to do it. And we have, from the very beginning of this lockdown period, used this very effectively to communicate with others. We have this weekly program of colloquia that now we don't have to get people from abroad to come and pay them plane fare. They can talk from their their homes, and we have got experts from all over the world to talk to people here in India. Here's Martin Rees For example, one of my teachers in Cambridge, who's of course, the president of the Royal Society and Master of Trinity College, Cambridge. And he gave us a wonderful talk recently. Yesterday, Rainer Weiss, who's the LIGO Nobel laureate from 3 years ago from MIT, talked to the children of India in one of our programs. And he had said that I would only talk to children about their life and career and why science is exciting. And we had this wonderful program interaction with him online as part of the Pulastya Festival here in Pune. Him sitting in Boston where he lives. We also did amazing online teacher training for school teachers and college teachers, national level workshop. And in each of these teacher training programs, we talked about how to use low-cost toys in class. As you know, Dr. Arvind Gupta worked in IUCAA for many years developing science toys. He was given the Padma Shri last year for it. With low-cost material, from thrown away slippers and shoes and things like that. And you can make demonstrations in class, and you can use them in schools and in colleges. And we also looked at how people can use phone apps and things like that. And each of these workshops that we have held over the last few months have had about 1,000 people joining from schools and colleges, and many of you who are listening might have been part of that too. There were state level ones in Marathi within Maharashtra, and then we had national level ones in English and in Hindi. And so, registrations were few hundred at a time. So I'll stop here and go for questions, but I just wanted to put up some of these links on Twitter. We are IUCAA Pune and IUCAA SciPop. This is our handle. You can look on Facebook, IUCAA SciPop, for our interaction with the schools and with the general public. And you can look at IUCAA's own Facebook page for our research news. On Instagram and in generally our YouTube channel is IUCAA SciPop, and we put almost all our events that I talked about there on our YouTube channel, either on the SciPop channel or on IUCAA's own YouTube channel. I will end the slideshow and we'll go back to looking at questions.
Thank you, sir. Thanks a lot. Very nice presentation, and our audience get an idea about the different activities ongoing at the IUCAA, as well as the different research facilities available at IUCAA. So they now understood that to go beyond the mountain to look what the universe is telling us, that is needful. And we have elaborated the different research institutes which are related with the astronomy and astrophysics nearby Pune city, like GMRT and all. So thanks a lot. This will definitely help to our youngsters, those are interested to do the research careers in astronomy and astrophysics. So in a similar line, I would like to ask you a few questions related with this. So my first question is that what is the use of astronomy? Basically, how the learning of it affects the real life.
So I started saying this in the presentation, of course, but there wasn't enough time to talk about such things. But I can say a little more. Astronomy in real life, of course, the use of astronomy is in almost everything that we do. As I said, even if you are not an academic, in your daily life, you are looking at your festivals, your religious festivals, your every occasion that you have is based on some astronomical calendar. And from a long time, that has been the motivation of studying the sky, to make sure that our auspicious days are all accounted for. But that is for the general public. But in general, I think astronomy, as I said, the most challenging fields in knowledge as a whole. It brings together philosophy on one side and mathematics, physics, and chemistry on the other side, and brings them together. And now we talk about astrobiology, astrostatistics, astroengineering, and things like that. And that is because these challenges of understanding the universe, we ask the biggest questions in the universe. and how big the universe is, how old the universe is, how did we get here, what are we made of, and things like that. And to understand these big questions, you have to bring in all kinds of knowledges that you have, and all subjects that you have. And so that in getting there, in understanding those things, you develop a lot of things that then are used everywhere else. As I said, we wanted to build a digital camera so that we could study very far away galaxies. Now it is in your pocket, in every single pocket, in every single phone, of all individuals all over the world. So in just trying to understand the biggest questions, you all develop the most useful tools that you need. And our forefathers developed the mathematics like Aryabhatta and Bhaskara to understand the sky. And now we make phone cameras to understand the sky. And they all are equally useful. So that is why I think astronomy is one of the basic tools, basic subjects that everybody needs to learn. And then it's also great fun.
Yeah. So thank you, sir. Very nice answer, actually. Since to understand the origin of life, I think this is a very important to study the astronomy as per your answer. So the next question is that from our childhood, actually we are looking towards the Dhruvadara and we are listening a lot of stories about it. So is the real astronomy or astrophysics is the simple like that one? Accordingly, means I would like to ask you that what is the difference between the study of real astronomy or astrophysics and the sky view, we can say?
Yeah. Excellent question. It's absolutely excellent question. And that's, people don't understand that. Often people confuse astronomy with astrology, and also astronomy and astrophysics, they don't understand the basic difference. Astronomy and astrology, they are very, very old subjects, and people have studied the sky for a long time, for reasons I just told you. I mean, even if farmers want to know when the crops will be sowed and harvest will happen, etc., you need to know the sky. And so that is a study of the sky in astronomy. Even if you do it for recreational purposes, like nowadays looking through a telescope and look at stars or planets and things like that, that is astronomy. Astrophysics is a very new subject. It only is less than 100, it's about 100 years old maybe, because actually it started with Newton applying the laws of physics to find out how things go around the sun and how comets come back, etc. But we have only started understanding how big the universe is, and what stars are, what kinds of stars there are, etc., by applying the laws of physics from the 20th century. And we only found out how big the universe is or how old the universe is only 100 years ago. We did not know anything like that maybe 200 years ago. So even when Einstein was publishing his theory of relativity, he did not know how old the universe is. And things like that. So we are now discovering, and that is what I call astrophysics. What we want to understand, the physics of the star. What is a star? What's inside the star? What makes up the star? And these questions we only started answering in the 1930s, 1940s, that kind of time. And only now we know what is inside the sun, and we knew how big the sun is, but what is in it? And how many kinds of suns are there? The first planet around another sun was discovered only in 1995. So this is a new subject, and this is where the physics and chemistry and mathematics meets astronomy. And this is the way forward, because now we are not only looking at positional astronomy and looking at the sky and describing the sky and understanding the beauty of it, which is the philosophy and the mathematics of it, but also the physics of it. And that is astrophysics.
Thank you, sir. Very nice answer. Actually, this will definitely help to the students to understand the basic regarding the astronomy. Now, the next question is that, do you think that India is lagging in the basic research of basic science like astronomy and astrophysics? Since we have a number of research centers like NCRA, TIFR, IUCAA, GMRT itself in Pune city, but the component from this area, I consider the of students, then are they lagging? What do you think about it?
No, I think the Pune area in general has some of the smartest students I've ever met, and the education system in Pune in general. And as I said, we deal with a lot of the education both at school and college level all over the country. And I have spent 25 years myself abroad teaching in some of the top universities in the world. And I can tell you that the education system in Pune is not lagging at all. What is and now will be addressed by the national education policy that is now being dealt with by the government, is that we have had an educational system that is very old-fashioned, in that it has not adapted to the new subjects that are being created, like astronomy, which is and astrophysics. That's an example of the new kinds of biology, the new kinds of chemistry and nanosciences that are being done, etc. The new kinds of medicine that we have to do. The connect between research and teaching has been missing in India. From the very beginning, after independence, research and education were separated. It doesn't happen anywhere in the world. Nowhere in the world are research institutions outside universities. Only in India, you have in places like IUCAA and TIFR and others, they are not inside universities. They are not connected to universities. And now we are doing that. In the national education policy, we have said that research will come into our teaching. Students will do research. This is being developed in the last 10 years through the ICERs do this now. And now through the new education policy in various colleges, in the college curricula, we are going to look at modern subjects. We are going to change the subjects. Similarly, a lot of this is now, as I said, percolating down to school education. So I think our exposure has been, because our education system has been not upgraded enough, and the connection with research has not been there. And that is why I think a lot of our students have thought that, okay, the best education is abroad, we go abroad. But I can tell you the teaching I had in India from my teachers in India were much better than the teaching I had in Oxford or Cambridge. I think it's the system that is different abroad. And I think we need to upgrade our system. We are doing it already. And we can have the best education sitting here in Pune. And then, as I said, we will have the best research facilities in India as well. So I think we're moving in the right direction.
Okay, thank you very much, sir. And we are feeling proud to that in Pune city, that is the educational hub. Actually, since you have a lot of experience in the abroad, and still you are confident that Pune is the educational hub. And in future, education as well as research have to go hand in hand together. So thank you very much. Now I would like to request Jayesh to ask 2 questions.
Okay. Yes. Good morning, sir. Yes. Good morning, sir. I'm actually a third year BSc Physics student. So, yeah, my question was that could you please tell us about the nature of dark matter and about CDM theory as well?
Okay, so I did not go into any details of astronomy in my presentation because, I mean, these are the research subjects that we deal with. Of course, in our research here, we deal with everything. We deal with what the sun is, the planets, and the stars, how the stars go, and the galaxies, and the universe as a whole. And as I said, some of the biggest questions we ask is, what is the universe made of, and how old it is? And they're connected. So we now know, of course, that the universe is mostly made up of dark matter, a matter that we don't see, because it does not produce light. Why doesn't it produce light? Because dark matter is, most of the matter in the universe is in the form of particles that don't form stars. And only when you form stars and you have nuclear reactions in the center, like our sun, that produces light. But since this matter is distributed all over the universe, and it can form, it can be around galaxies and things like that, but it does not form stars. How do we know that? Because matter itself, all matter has gravitation. And so we can feel the gravitation of these particles that are there. For example, we can see, we live in a galaxy, as you know, called the Milky Way. And even in our galaxy and galaxies like us, if you go outside the galaxy in terms of the stars, where the stars are, and you go far away, you still see that you can get more and more gravitational pull on you. And you can measure this. I'm not saying I have been there, but we can look at stars or particles and look at their motion and see there's more and more and more matter pulling it. And that means there is more matter outside the stars in a galaxy. And there's quite a lot of it. And if you add it all up, it turns out that almost 80 to 90% of the matter in the universe is in this form, which doesn't form stars, but but has gravitation. Now, what is the nature of this? And so from the 70s, when this was first discovered in the 60s, 70s, people have started saying maybe these are neutrinos, which is called hot dark matter, or maybe it is large particles like MEV particles, like axions or massive neutrinos and things like that, which is cold dark matter. And so now we know it is cold dark matter. It's very massive particles, but we haven't been able to detect them yet. We know it is there through their gravitation, but we haven't found a single experiment in which they are directly detected, because these things don't interact with normal matter like us. So this is a great puzzle. And so this is something that in this century, people like you and your colleagues are going to work on this to find out the nature of dark matter. We have detected them, we have found them, we've discovered them. Now we're applying physics to find what it is.
Thanks a lot, sir.
Thank you.
Okay, I have one more question. Recently, that excess phosphine was discovered in the atmosphere of Venus. So, that can we expect that there may be life in future?
Very
on
interesting
Venus?
question. I mean, yeah, very, very interesting question. So what happened was phosphine was discovered in Venus. That is interesting, very interesting, because phosphine we know is associated with life. In bacteria produce phosphine. There are some bacteria, and the quantities of phosphine that was found in Venus is much more than can be naturally produced. Naturally, it is produced in volcanoes, in some chemical reactions that are underneath, even on Earth. You have phosphine that is produced in various places, but it's very, very tiny. The discovery in Venus was that a lot of phosphine. Now, the people who discovered it themselves said that this does not mean that there is life on Venus. We have to wait and see, because we have to first verify a couple of things. And, we have ISRO is going to send also our own Shukrayan, which is going to go to Venus and look for these things. People are now going to, first of all, check whether the phosphine measurement is right or not. It needs second checking. It could be a wrong measurement, but always in science we have to check. And then we have to eliminate other things, because Venus's atmosphere is full of sulfuric acid and carbon dioxide and things like that, very, very hostile. And the surface of Venus is 600 degrees hot. So, can think of the kind of life that can exist in Venus must be very different from the life we are used to. And so where did this phosphine come from? It's a great puzzle. I think people are trying to figure out whether there are any other processes that can create phosphine. It is possible that in the atmosphere of Venus there can be bacteria that produce these things, but where did these bacteria come from? We don't know. So we're not ruling out anything. In science, we are used to all kinds of surprises, and sometimes these discoveries reveal things that we've never thought of before. And the history of science and astronomy is full of such discoveries which completely puzzle people, and slowly we figure out what was there, right? And so when, for example, pulsars were discovered, am I still there?
Yes, sir.
Yes. When pulsars were discovered in the 1960s, for which the Nobel Prize was given, people thought that these were signals sent to us from extraterrestrial intelligence. And for a long time, the pulsars were called little green men. And then we realized these are rotating neutron stars. And of course, we never knew about rotating neutron stars. The physics we hadn't worked out before. So we have to work out what phosphine means. And that is very interesting. It's an interesting subject.
Yeah. Thanks a lot, sir. Okay, now I'll request Vivek to take few questions. Okay.
Vivek?
Good morning, sir.
Morning.
It's been an honor to be in presence with such distinguished personalities. I would be humbled if you could answer a couple of my questions. First, I would ask about the contribution of Roger Penrose, the current Nobel Prize winner in this subject of formation of black holes. We would like to know more about that.
So I think it's one of the greatest Nobel Prizes that has been given, I think, because in Nobel Prize history, Nobel Prizes were never given for theoretical work, because Nobel himself, in his will, said that it should be given to applicable work. And then people interpreted that for a long time for things that are actually discoveries, inventions that are made, that are used in instruments or in daily life. But then, as I pointed out, people realize that in theoretical work and in subjects like astronomy, we actually build the mechanisms that lead to quite a lot of applicable work later on. So what I think is theoretical work now can be applicable later on. So this is why in the last 2 or 3 decades, a lot of theoreticians have got Nobel Prizes. Chandrasekhar got the Nobel Prize, Higgs got the Nobel Prize, and now Penrose. And I'm sad that Stephen Hawking didn't live long enough to get this Nobel Prize. So the contribution of Hawking and Penrose has been that black holes are, of course, I have to give a whole lecture on this. I don't want to do that now, and I've been giving quite a lot of Nobel lectures in the recent days. You can go to YouTube and look at one of my lectures to find out what the significance of black holes are. But black holes are things that are very exotic. At the end of the life of a star, the star collapses. Some stars that are massive, they collapse, and there is nothing to stop this collapse, because during the lifetime of a star, the energy they produce balance the gravity, and after the energy they produce, the light they produce is finished, then the star collapses, and nothing to stop it. And then in traditional physics, you can think of the star collapsing and going into a point which is called a singularity, where the density will be infinite and everything will blow up, and mathematically you can't deal with it. But Penrose and Hawking showed very nicely, using Einstein's theory of relativity, that this comes naturally from physics and mathematics, this collapse, and it does not create something that is not allowed in mathematics. They gave a formalism to it. And to do that, they used the formalism worked out by an Indian physicist called Amal Kumar Raychaudhury, the Raychaudhury equation, which is a formalism set up in general relativity that takes into account rotation and shear and everything, and shows us the mathematics, how to work it out. And so they've been given this Nobel Prize for mathematically showing how black holes can exist to some extent, without leading into infinities and singularities. All I can say now is that, of course, we can give a whole lecture on this. There's a lot of material now on the web you can find which tries and explain this, and this will take a long time to explain, but please go and read that. Thank you.
Thank you, sir.
Thank you.
It's been an honor.
Vivek, actually, we have a lot of questions. So
Okay,
the
sir.
next, we have students of Jnana Prabodhini, 7th standard students. So I would like to ask Veera to ask a few questions.
So, sir, I am Ira Kulkarni from Jnana Prabodhini Prashala, and she's Anahita Joshi from the same school and same class.
Very good to meet you.
So, yes, thank you, sir.
It's an honor to have you.
Exactly. So I had a few questions. First, what is the way we send satellites in space now? And is there any other way to send satellites in space excluding the way we use now?
So tell me your first question. What satellites? I'll repeat the first question that you asked.
How do we send satellites in space? And
It's okay. Very good. Yes.
way?
Yeah. Wonderful. First of all, let me say Jnana Prabodhini is one of the leading schools in Pune who have always taken part in IUCAA's programs. Every year when we hold our science quiz and science competitions, your school comes out as one of the winners. And we've worked with your school for a long time. So I'm very proud that a school like yours exists in Pune. The question is very interesting. Of course, what we have to do is if you want to send a satellite out in space, is to escape from the Earth. So escape the gravity of the Earth, and that is called escape velocity. It's something that you will learn very soon in school, I think. When you learn Newton's laws, etc., you will know that all objects pull each other through the force of gravitation. And in order to escape from gravitation, so for example, if I jump on the Earth, I cannot really fly away into space. And that is because you need a certain energy, certain velocity in order to fly away in space. And for the Earth, that velocity is about 40,000 kilometers per hour. Our car doesn't go beyond 100 kilometers per hour. Police will catch me. So 40,000 kilometers per hour is a big speed, and that is the velocity you need to escape the gravity of the Earth into going to space. So to do that, what space agencies like ISRO and NASA and ESA do is that they try to figure out what is the best way to send something in space and attain this velocity. Anything that attains this velocity is going to go into space, right? Now, in order to do that, amount of energy that you need is very much, and you need a lot of fuel to give this a boost, like a plane taking off or a car starting needs some fuel to give it a boost. And the way, and in India, we don't have launchers that are so powerful. Only the Apollo mission used direct launching of rockets to go to the moon. We don't have that. So we have very clever ways of launching these satellites into space, where we go in various orbits around the Earth and take the rockets or the launchers to a very high altitude, where this escape velocity is much less, because we are far away from the Earth. And from that, we then burn some fuel and launch things into space. And you can see, if you look at the orbits of how we sent our Mangalyaan and Chandrayaan, you will see that they go in orbits like that, and finally go boom. So that is the Indian way of using the gravity of the Earth, and also using less fuel, a very cheap way of sending things into space. And things are evolving. I mean, of course, India's, if you look at the launches, the PSLV and the GSLV, etc., they have very different technologies, and we have we are using various different kinds of technologies in order to launch in different ways. But it all boils down to that fact: you need that escape velocity, and that's one of the reasons you cannot jump into space on your own. Any other question?
Yes, sir. Actually, chat box. A few of them I will ask you. Sorry, Ira and Nika, since we have a lot of questions.
Anahita, do you have any questions? Out of them, I can answer one of their questions.
Any one question?
Yeah.
Okay, go on.
So I have a question. Is Earth's changing atmosphere affecting the moon?
Affecting the moon?
Yeah.
Yeah. So no, not really. Very, very good question. Interesting question. See, moon doesn't have its own atmosphere. It has very, very thin atmosphere, because it's not. As I said, this escape velocity is very important, and moon is very small, and so as a result, it doesn't have enough gravity to hold on to an atmosphere. And the gas that is on that was on the moon, like on the Earth, they moved. The gas particles always move around, and their velocities were big enough that they could escape from the moon. So the moon has lost its atmosphere. Now, the way I can interpret your question is that the changing atmosphere of the Earth is changing the way we look at the moon, because sometimes you look at the moon and you see it in different colors, and that is because the composition of our atmosphere is changing. And as a result, sometimes, even now, when the moon rises or the moon sets, the colors are different, because the amount of dust and the amount of different composition of gas in the Earth's atmosphere is changing, and that is why. But it doesn't directly affect the moon, because this is how we look at the moon. Moon does not have an atmosphere of its own, and so it cannot pollute its atmosphere. And so that I think is the direct answer to your question. I don't know whether you had anything else in mind.
No, sir. No, sir.
Okay. Thanks, Ira. And I have next question. So the question is that
sorry, I can't hear your voice. Is the question in the chat? Is the question in the chat box, or it's no? It's in the YouTube channel. No.
I'll ask you, sir.
Can you write the question in the chat box, or you can say yes. Now I can hear you. Yes, go ahead. Please say it again.
The student Ranjal is in Pune, actually. She want to ask you that how she can do the project in IUCAA.
Right. So that's a good question. As I said, IUCAA is a very small place, and so we have only a few faculty, and we have all these teachers who come and work here. So we typically have various levels of projects. In the summer, for example, and in the summer we have summer schools and summer projects in which school students can come and spend a week or 2 weeks here doing projects with various IUCAA people. And so if you look at our IUCAA SciPop web page, you will have great, of course, now with the pandemic, everything is closed, but I hope we'll open again soon. This year it was cancelled, but in the summer, school students in the summer vacation can do projects in IUCAA, and about 200, 300 students come every year and do these with us. And slowly, what we are doing is that we have the MVS, and so we have setting up labs there with science toys and various other science learning activities, so that students can, from school students, they can come and in batches and do experiments there all through the year, not just in the summer. And they will come with their teachers and do things. And those programs are there on our website. For college students and university students, we have 2 kinds of projects. One is, of course, in the summer, and this is our vacation students program. And also nowadays, in many of these BSc and MSc programs, you can do a long project. And so those projects we have also, and many universities have students who do their long master's project or bachelor's project with our faculty. And so that is coordinated by our academic coordinator, so AOCP at IUCAA. If you write to us, you can find out about them. Also on our website, there is quite a lot of detail on what kind of projects that we done. But another important thing is we have these 150, 160 associates all over in the country who are associated with us. They also guide students to do, and we have 15 centers all over India, which I didn't talk about, which are called iCards. One of them is in Ferguson College in Pune, actually. And these centers have people who also can help you do your projects. And so, for example, if you are not in Pune but somewhere else and want to do a project related to your academic work, you can work with the person who is in the center nearest to you, who's associated with IUCAA, and they will guide them. And so through this whole network, we have lots of people who do projects.
Yeah. Thank you, sir. So the next question is that astronomy is really vast, and this field is expanding like anything. So what more career options will be there in coming decades?
Very good question. And this is the crux of what I wanted to say all through. Astronomy is a new subject. It is where, say, quantum mechanics was 100 years ago. It's just started. Why is it just started? Because we just have telescopes big enough and good enough to study the universe only in the last 20, 30 years. And you see these big discoveries being made. And we've sent telescopes into space only from the 1980s, right? And that has opened up the whole band of other kinds of things like X-rays and gamma rays and infrared and microwaves, which don't come through the atmosphere. You have to study them from outside the atmosphere. And we couldn't, before that, study the X-rays coming from the universe, from all kinds of stars. And this is how we now discover black holes. And then we have now discovered gravitational waves. So astronomy is just starting, I think. Astrophysics is just starting. It's a subject. And so I think very exciting career opportunities. This century is the century of biology and of astrophysics, I think, where wonderful discoveries will be made in both these subjects, in biomedical and in understanding the molecular nature of biology and understanding the physical nature of the universe. So career opportunities are there. And as I said, what we are trying to do is to make sure all universities have astronomy in their curriculum. Many universities do. You can already have astronomy courses as part of your undergraduate. And then your postgraduate education, many universities have in the physics, mathematics, or engineering departments, they have astronomy in. Even if you don't do that, you can go and do a PhD in astronomy in many of the institutes all over India. And many universities now have astronomy PhD programs. The university, for example, has astronomy PhD program in their physics department, along with IUCAA. And what we see, I mean, we only take 10 students every year, and that comes through a national exam, which is called JEST, which actually is an exam that you have to take to do a PhD program in any physics subjects in about 65 different institutions in India. They're all together in one It's like the JEE for engineering colleges. And JEST happens once a year. And then also in IUCAA, we have another IUCAA National Astronomy test that happens in December. So these two are the ways that you can get into IUCAA. But you can get into any other institution. There is ARIES in Nainital, there's TIFR, there's in Bangalore, there are 3 institutions, IISc, RRI, and Indian Institute of Astrophysics. And there are many universities in which you can do a PhD. For doing the PhD, you can come from physics or mathematics or engineering. I mean, half of our students come from engineering. And so you can go to an engineering college and get some knowledge of doing some kind of engineering and then come into astronomy. So I think career opportunities are opening up. And I showed you that the reason I told you about the TMT and the LIGO and AstroSat and things like that is that ISRO is now planning 5 different astronomy missions after AstroSat that will go up in the next 10-15 years. So this subject is going to become mainstream in India, I think. And so there will be job opportunities and opportunities of being very innovative and doing world-leading work. That's the most important thing.
Thank you very much, sir. The next question from Senior Professor Kulkarni, actually. He's asking that it was actually, he told us that it was a wonderful presentation. And can you elaborate on the spin-offs of LIGO experiment? And in association with this, I may also ask that which are the opportunities in this LIGO?
Yes. So as you see, LIGO experiment involves measuring displacements in an optical system of 10 to the power minus 18 meters. This is the smallest displacements ever measured. And also this it's an interferometer, a laser interferometer that is enclosed in 4-kilometer long tubes that are the highest vacuum in the world, 10 to the power minus 9 torr, and things like that. So it pushes technology to anything. Now the kind of displacements we are measuring, it's smaller than the size of the nucleus, but you can see that around you, around the experiment, there are vibrations that are even much more. Even a train going 30 kilometers away from the experiment creates a vibration of the ground that is much more than this, right? In fact, in the LIGO experiment in the US, every single wave that hits the coast of the 2 coasts of the US can be detected. When we first detected the LIGO first detection in September 2015 from the US in Washington state, we were worried whether we had detected a lightning storm in Kenya, in Nairobi, right? And so that kind of measurements are made. So then you can see, to do that, the technology that one has to develop, and everything will be made in India now, is that Indian companies will have to be pushed to create these things. Now we have to build the tubes are made of steel, the 4-kilometer tubes, such that when you have the highest vacuum in the world, it does not outgas and destroy the vacuum. We are looking for companies who will make them. And the biggest companies are not interested. We are looking for smaller companies who will make this research equipment, and they'll have to weld this and things like that. So in mechanical engineering, in vacuum technologies, in optoelectronics, in electronics, in lasers, and in physics, a lot of opportunities. There are spin-offs from LIGO, and they all go to, and so we now have held these meetings here every few months, bringing together people from the national universities and companies to come and talk to us about the challenges. And so they go back, and so now we have about 20 different university departments of engineering and physics working with us on various problems. Looking at the challenges, because we are using things that are never been done before in India, and so now we can learn from things that have been achieved elsewhere, but also develop our own solutions. So that's also
Thank you, sir. Now the next question is that from Tushar, that is parallel inverse exist, and what is your opinion on multi-inverse?
So it's a very good question, and my opinion does not matter, but I have an opinion, and I think they exist. because why should there be only one universe? This whole concept is very interesting. And it just says that there may be many universes with different laws of physics in them, and so they have different histories. So the speed of light here is one, and then in another universe the speed of light might be different, and things like that, and there will be many of them. And then in certain universes there will be stars that will be created and life will be created, etc., etc. So I think that is a very nice concept. There is no way of proving it in the physics that we know now, because we can't go outside our universe, or we cannot really get any information from outside the universe with current technology and current physics. And so it's a very interesting concept. I personally believe in it, but I'm waiting for somebody to come up with a way of proving the existence of other universes, and that would be very interesting. Any other questions? Can you hear me?
Sorry, sir. I will have asked you that the solar system is made up of nebula, but how these nebulas are formed?
That is not quite right. The solar system does not have nebulae. Nebulae are clouds of gas that are clouds of stars. The concept of nebula is a very old concept. When people didn't know about galaxies and stars, they looked at the sky and they saw that there are some stars that look fuzzy. A nebula means nebulous, of course. They look like cotton wool. And so they thought, what are these things? And so about 100 years ago, people figured that some of these nebulae are actually millions of stars together called galaxies, and they're very far away and they look fuzzy. But some of these are also stars, single stars that have exploded, and they're supernovae and supernova remnants, and they look like fuzzy objects, not point objects. So these are called nebulae. I don't know whether you're thinking of, in the solar system, other objects other than the planets. There are, of course, asteroids. There are comets. Comets can be nebulous, but these things are there in the solar system. But other than that, there is no other nebula in the solar system. All the nebulae are outside the solar system. They can either be coming from stars, or they can be outside our galaxy, and there are whole galaxies that look very nebulous, and they look like single stars, but we have now figured out that those have 10 to the power 10, 10 to the power 11 stars in them, and then there are whole galaxies like the Milky Way, which are nebulous. I hope that answers your question.
Yeah, sir. So the next question is from MA, probably the last one. That is, as a dark matter only interact via gravity, and does Indian LIGO have the technology to by any chance detect any interactions with the dark matter?
No, Indian LIGO is, of course, not very different from any other LIGO in gravitational wave detectors. Currently, the technology that we have can only detect the very extreme gravitational interactions, because the amplitude of the gravitational wave is very, very tiny, and we have just only started. So it's like Galileo building its first telescope and looking at the surface of the moon. That kind of technology, and that's why the things that we are now detecting are the collisions of black holes, two black holes becoming one black hole, or two neutron stars becoming one black hole, and things like that. Dark matter does not form stars, so dark matter does not collide, and dark matter interacts. So the way gravitational waves happen is that they have to come from an asymmetric object, which is actually a star-like thing that will either explode asymmetrically or collide with each other, and that will cause the space itself to vibrate. But dark matter is diffuse; it's everywhere, and so when dark matter moves, it does not vibrate space in the way that when stars collide they do, right? So in order to detect dark matter through gravitational waves, I think we'll require another many hundreds of years of technology evolving to go to that kind of detection. Maybe indirectly we can detect them, but that is not a good way of detecting dark
Okay, thank you, sir. Now, the Mangesh asked us that an European country planning to send a group of persons to Mars on one-way trip. What is your opinion about it?
I think eventually it's going to happen. Whether it happens now or later, I don't know. Right now, people are not only European countries. There are American companies who also have plans for this. I have a student from when I used to teach abroad. One of my students from then is an astronaut who's trained to go to Mars, and she has decided that she will go to Mars if any company takes her. So there are many people who are willing to do this now, though I don't know whether it's going to happen, because our technology is not good enough, because to go to Mars it will take a few years, and we only have gone to the moon and back, and that has taken a few days. For people to be in a spacecraft that they can be there for years and then it's a one-way trip, you're not coming back, is a different problem that needs to be first worked on. The sociological problem needs to be worked on. How to feed them, how to take them for long voyages like that has to be worked on. So I don't think we have the technology really yet for safely taking people to Mars, but it's going to happen soon. And I think it is inevitable that people will go and explore other planets. It's a question of when it's going to happen.
Sir, in association with this, I would like to ask you that what is the possibility of life on the other planets?
Yeah, I think this phosphine on Venus caused a lot of excitement, but I think most of the planets have now been explored, and we don't see any form of life at all. In fact, phosphine also might have come from some kind of bacteria, which is not very complex life, but it's possible. But I think eventually we will find that that it's not a kind of life that has produced that phosphine. There are some moons of some of the planets, like Europa, for example, and which has quite a lot of water. And underneath that water, there are conditions for life. And if we find life in the solar system, I think we're more likely to find them not on the planets, but on one or two of the moons. Life is very difficult to form, and I think it is not easy. I believe personally that there is life elsewhere in the universe, somewhere on some other planet. I'm a little skeptical about it being within our solar system. As I said, it's very rare, and but now we know of about 5,000-6,000 planets around other stars, and that number is growing. And maybe we will soon find biological signatures or life signatures on some other planet around some other sun.
Thank you, sir. Thanks a lot for this nice session. Actually, you had given all answers. A lot of questions actually we have asked, and we understood that if we have to study the astronomy, astrophysics, then we have to look beyond the mountain. And for your nice presentation and this talk, thanks a lot. So now I hand over this session to Mukul.
Thank you.
Mukul sir, please unmute yourself. Yeah.
No, his sound is
on. Hello, can you hear now?
Yeah.
It feels the session should go on, but due to time limitations, we have to stop here. Thank you, sir, for your time and valuable inputs. I thank all the participants for the questions that you have asked. You can follow Vidnyan Bharati on our page, IUCAA Pune, and see you all in the next Vidnyan Samvad, second Sunday next month. Thank you so much.
Thank you very much. Thank you.
Thank you very much.
Thank you.
Thank you all. Very good questions. Thank you very much.
Yeah.